What's going on, everybody? Welcome back to my YouTube channel. Let's solve this math question which says find the values of y for which 64y to the 6 is equal to 729. Well, our first step will be for us to write 64 in its index form. So 64 is same as 2 to the 6. And this is y to the 6 equal to, now we also have to write 729 in its index form. So the index form of 729 is 3 to the 6. Very good. Now our next step will be for us to apply the law of indices on the left hand side. The law of indices which says when I have, for example, a to the m times b to the m, as long as they have the same exponent, this can be combined. So it can be written as ab all raised to the m. So we're going to be writing this in this form. So this becomes 2y all raised to the common exponent 6. And this is equal to 3 to the 6. Very good. Now our next step will be for us to move 3 to the 6 to the left hand side. And in order to do that, I'm going to be subtracting 3 to the 6 from both sides. So subtracting 3 to the 6 from both sides, you notice that on the left, I have 2y all raised to the 6 minus 3 to the 6. And this is equal to, on the right hand side, 3 to the 6 minus 3 to the 6 cancels out, so leaving behind 0. Now notice that this expression is same as 2y all raised to the 6 is 3 times 2 minus, we're going to write this the same way. So this will be 3 to the 6 is same as 3 times 2. And this is equal to 0. Very good. Now our next step will be for us to apply the law of indices, which says when I have, for example, a to the m times n, this is same as a to the m and then raised to the n. So we're going to write this in this form. So this becomes 2y raised to the 3, and this will be raised to the power of 2. Minus, we do this the same way. This becomes 3 to the 3, and this is raised to the 2. Very good. This is equal to 0. So we have an expression in difference of two squares. An expression in difference of two squares has a property. For example, when I have a squared minus b squared, which is difference of two squares, this can be expressed as a minus b times a plus b. Now we're going to be writing this in this form. Now notice that a is in the form of 2y all raised to the 3, and then our b is in the form of 3 to the 3. Now writing this in this form, this is a minus b, so this is a minus b. Very good. And then times a plus b, so a, that's 2y cubed plus b, which is 3 cubed. Very good. And this is equal to 0. So we have two cases here that we're going to be solving one after the other. So the first case is 2y all raised to the 3 minus 3 to the 3 is equal to 0. Or the second case is 2y all raised to the 3 plus 3 to the 3 is equal to 0. Now let's focus on the first case. So let's say for case 1, case 1, we have 2y all cube minus 3 to the 3 equal to 0. Now, when looking at this expression, you see that we have an expression in difference of 2 cubes. An expression of difference of two cubes, for example, when we have a cube minus b cube, this has a property of a minus b times a squared plus ab plus b squared. So we're going to be writing this in this property. Good. And when looking at our expression by comparing, you see that a is in the form of 2y and that our b is in the form of 3. Okay, writing in this form, we have a minus b. A is 2y minus b, which is 3. Very good. Times a squared, that's 2y all squared, that's our a squared, plus ab. A is 2y times b, b is 3, and then plus b squared, which is 3 squared. Very good. Then close bracket equal to 0. Very good. Now let's simplify what we have in this parenthesis. So we have 2y minus 3 times 2y all raised to power 2 gives 4y. Okay, 4y squared rather, because these two affects what is inside of the bracket. So 2 squared is 4 and y squared. Good. Plus 2y times 3 is 6y. And then plus 3 squared is 9. And this is equal to 0. So we have two cases. The first case is where we have 2y minus 3 to be equal to 0. And then the second case is where we have 4y squared plus 6y plus 9 equal to 0. We're going to be solving these cases one after the other. Now for the first case, let's say case 1. This is where we have 2y minus 3 equal to 0. Now I'm going to be moving this negative 3 to the right hand side, and I'll do that by adding 3 to both sides. Now on the left, negative 3 plus 3 cancels out, leaving behind 2y on the left equal to, on the right, 0 plus 3 is 3. And in order to get the value of y, we divide both sides by 2. So I'll divide the left by 2, I'll divide the right by 2. So 2 cancels 2, leaving behind y to be equal to 3 all over 2. Very good. So that's for our case 1. Now for our case 2, remember our case 2 is 4y squared plus 6y plus 9 equal to 0. Well, this quadratic equation cannot be factorized, so we're going to be using the quadratic formula to solve this. Now, using quadratic formula means we're going to have our a. A is the coefficient of y squared, which is 4. B is the coefficient of y, which is 6. And then C is the constant term, 9. Very good. And now, since we're looking for the value of y, the quadratic formula is y equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, let's substitute into our quadratic formula. So this we have y to be equal to negative b. What is b? B is 6 plus or minus the square root of b squared, that's 6 squared, minus 4 times a times c. So 4 times a is 4, times c is 9. All over the denominator 2 times a, which is 2 times 4. So this simplifies into y equal to negative 6 plus or minus the square root of 6 squared is 36 minus 4 times 4 times 9 is 144. All over 2 times 4, that's 8. And this simplifies into y equal to, we have negative 6 plus or minus the square root of 36 minus 144 gives negative 108. All over the denominator 8. Very good. Now we're going to break down negative 108 into its various factors, in which one of its factors must be a perfect square. So we have y to be equal to negative 6 plus or minus. Now breaking this down, we have 36 times 3. 36 times 3 gives 108. Then to get the negative, we multiply by negative 1. Very good. All over the denominator 8. And now simplifying further, I'll be splitting this. So we have y to be equal to negative 6 plus or minus the square root of 36. Remember, I'm splitting, times the square root of 3, and then times the square root of negative 1. All over the denominator 8. Now we all know that the square root of 36, which is the perfect square, is 6. So this will result to, no, I have to do this as well. The square root of negative 1 is iota, which is represented by I. So on multiplying, we have y to be negative 6 plus or minus. Now 6 times the square root of 3 times I gives 6 root 3 I. Very good. All over 8. And if we have to factorize, you notice that 6 is common. So let's factor out 6. Open up brackets. Negative 6 divided by 6, I have negative 1 plus or minus 6 root 3i divided by 6, I have root 3i. So this is root 3i. Very good. All over 8. 6 divided by 2, I have 3. 8 divided by 2, I have 4. So this makes the value of y to be 3 times negative 1 plus or minus the square root of 3i all over 4. So there are actually two values of y from here. Remember, we've got one value of y already. So this is going to be our second value of y, which is 3, open bracket, negative 1. We'll go with a plus first, plus the square root of 3i all over 4. So that's the second value of y. And then the third value of y is 3 times negative 1. This time, go with the negative square root of 3i all over 4. Very good. So these two are complex solutions. Now let's move on to our case 2. So our case 2, we have 2y all raised to the power of 3 plus 3 to the 3 equal to 0. Very good. Now notice that we have an expression of sum of two cubes. An expression of sum of two cubes, for example, when I have a cube plus b cube, this has a property of a plus b times a squared minus ab plus b squared. Now, let's apply this to what we have here. But we're going to be doing comparison. A is in the form of 2y, and then b is in the form of 3. So that means a plus b is 2y plus 3, and then times a squared, this is a, which is 2y all squared, minus ab, a is 2y, times b, b is 3, and then plus b squared, that is 3 squared. Very good. And this is equal to 0. So this simplifies into 2y plus 3 times, so the square of 2y gives 4y squared, minus 2y times 3 is 6y, and then plus 3 squared is 9. And this is equal to 0. So we have two cases here. The first case, we have 2y plus 3 to be equal to 0. And then the second case, we have 4y squared minus 6y plus 9 equal to 0. Now let's go with the first case so that we can get the value of y. Well, I'm going to be moving 3 to the right hand side. And in order to do that, I'll be subtracting 3 from both sides. So subtracting 3 from both sides, notice that from the left, plus 3 minus 3 cancels out, leaving behind 2y to be equal to, then on the right, 0 minus 3 is minus 3. Now to get the value of y, we divide both sides by the coefficient of y, which is 2. So divide both sides by 2. Notice that 2 cancels out 2, leaving behind y to be equal to negative 3 all over 2. So we can call this the fourth value of y, since we've already got 3. Now let's move on to our second case. So our second case, let me call this case 2. This is 4y squared minus 6y plus 9 equal to 0. This quadratic equation, just like the first one, cannot be factorized. So we have to use a quadratic formula. Our a from here is the coefficient of y squared, which is 4. Our b is a coefficient of y, which is negative 6. And our c is a constant term, 9. So since we're looking for y, our quadratic formula will look like y equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now substituting into our quadratic formula, we have y to be equal to negative b. So negative b is negative 6, plus or minus the square root of b squared, b is negative 6, and we're going to square that, minus 4 times a times c, that's 4 times a. What is a? A is 4 times c, c is 9, all over the denominator. 2 times a means 2 times 4. Good. And now simplifying further, we're going to have y to be equal to negative times negative makes this positive 6, plus or minus the square root of negative 6 squared is 36, minus 4 times 4 times 9 is 144, all over 2 times 4 is 8. And now simplifying what we have here, we're going to have y to be 6 plus or minus the square root of 36 minus 144 is negative 108 all over 8. Remember, we've simplified this before, so we're going to be using the result we've got from our previous case. So we have y to be 6 plus or minus the square root of negative 108 gives 6 root 3i. Remember from our previous case, all over 8. And then factorizing, 6 is common, so factor out 6, open bracket, 6 divided by 6 is 1, plus or minus, and then 6 root 3i divided by 6 is root 3i. Close bracket, all over 8. And now breaking down, 6 divided by 2 is 3, 8 divided by 2 is 4. So making y to be 3 times 1 plus or minus root 3i all over 4. So there are actually two values of y from here, and this will make the fifth value of y, which is 3 times 1 plus, we'll go with the plus first, root 3i all over 4. And then the sixth value of y is 3 times 1. This time go with the negative minus root 3i all over 4. Good. So we have in total 4 complex solutions and then 2 real solutions. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.